In July of 1942, a British Spitfire pilot wrote in his logbook, "The German Focke-Wulf turns like a knife through butter, while we fall like a heavy stone. This is impossible. It defies every principle of aerodynamics we know." These lines come from a declassified Royal Air Force document. The pilot's name was Squadron Leader James Douglas. He'd been flying since 1939. He had completed over 200 missions. He knew every Allied and German aircraft in the sky. And in the summer of 1942, he encountered the Focke-Wulf 190 for the first time. He did not survive the fight. His logbook was forwarded to RAF intelligence. There, it triggered alarm bells, because Douglas wasn't alone. Between May and August 1942, the Allies lost 487 fighters over the English Channel. Most fell victim to the Focke-Wulf 190. The loss rate was so dramatic that Winston Churchill himself ordered an investigation. What made this German aircraft so superior? Why couldn't Allied pilots, who had trained for months, suddenly compete? And above all, how did Germany manage to build a fighter plane that seemed to defy the laws of physics? The answer lies in a revolutionary design concept developed by Kurt Tank. Tank was the chief designer at Focke-Wulf. He wasn't just a theorist, he was a pilot. He knew what a fighter needed in aerial combat, and he knew that previous fighter planes all had the same flaw. They were optimized for speed, not for maneuverability. The Spitfire, the P-51 Mustang, the P-47 Thunderbolt. All of these machines were fast. They had powerful engines. They could reach high speeds. But in a tight turning fight, in a dogfight at close range, they were clumsy. They took time to turn. They lost energy in the turn. They became sluggish. Kurt Tank took a different approach. He asked himself, what happens if we don't design for maximum speed, but for maximum maneuverability? The answer was the Focke-Wulf 190. But before I tell you how the Allies reacted to this superiority, let me tell you about the day the Focke-Wulf first flew into combat. It was September 13th, 1941. Jagdgeschwader 26, stationed in France, received its first aircraft. The pilots were skeptical. They'd been flying the Messerschmitt Bf 109 for years. They knew this machine. They trusted it. And now they were supposed to switch to a new aircraft, in the middle of a war. First Lieutenant Otto Stamberger was the first to fly. He took off from Le Bourget. He climbed to 10,000 feet. He tested the controls. He tested the roll rate, and after 10 minutes he radioed back to base. "This isn't an airplane, it's a weapon." On the same day, 6 hours later, Stamberger encountered a formation of 6 British Spitfires, alone, 6 against 1. Normally a pilot would evade, call for reinforcement, escape the overwhelming odds. Stamberger did the opposite. He attacked. The British pilots saw him coming. They formed a combat formation. They expected a hit-and-run attack. Quick in, shoot, quick out. That was the standard tactic of the Bf 109. Stamberger did something different. He flew straight into the formation. He rolled. He turned. He danced between the Spitfires. He shot one down. Then a second. Then a third. The remaining 3 fled. Stamberger returned to base. His aircraft didn't have a single hit. The British pilots had fired, repeatedly, but they couldn't hit him. The Focke-Wulf was too maneuverable, too unpredictable, too fast in its response. This one battle changed everything. Within 2 weeks, the Luftwaffe ordered 1,000 more Focke-Wulf 190s. Within 3 months, they completely replaced the Bf 109 on the Western Front. The Focke-Wulf became the standard, and the British, they had no idea what was coming. Let me tell you about a moment that shook the RAF to its core. It was June 23, 1942. An aerial battle took place over the English Channel. 6 British Spitfires against 4 German Focke-Wulf 190s. According to standard logic, this was an even fight. 6 against 4. The British had numerical superiority. After 8 minutes, 5 Spitfires had been shot down. The 6th managed to escape, but only because it fled into the clouds. All 4 Focke-Wulfs returned to base undamaged. The RAF analyzed the radio recordings of the battle. What they heard shocked them. The British pilots weren't talking about cowardice or bad tactics. They were talking about physical impossibility. One pilot said, "I had him in my sights. I fired. He turned away, but not normally. He rolled. Completely. In less than 2 seconds. I lost sight of him. When I found him again, he was behind me. 2 seconds for a complete roll. That was 3 times faster than anything a Spitfire could do." The technical specifications of the Focke-Wulf 190 explain this phenomenon. The BMW 801 radial engine produced 1,700 horsepower. That wasn't extraordinary. The P-47 even had 2,000 horsepower, but the Focke-Wulf used this power differently. It distributed it more intelligently. Let me explain to you exactly how revolutionary this engine was. The BMW 801 was an air-cooled 14-cylinder double-row radial engine. Air-cooled means no coolant, no radiators, no lines that could be hit. If a Spitfire pilot took a hit to the radiator, the engine would overheat in 3 minutes. The pilot would have to make an emergency landing or bail out. The Focke-Wulf didn't have this problem. It could take massive damage and keep flying. There are documented cases of Focke-Wulf pilots returning to base with over 200 bullet holes. The engine was still running. The aircraft was still flying. But the BMW 801 had another advantage. It had an automatic engine management system, the first of its kind in the world. The pilot didn't have to worry about mixture, boost, RPM, or propeller pitch. He just moved one lever. The system controlled everything else automatically. In the Spitfire, the pilot had to operate 4 different levers, monitor 4 different gauges, make 4 different decisions simultaneously. While he was fighting, while he was evading, while he was aiming. That was cognitively overwhelming. In the Focke-Wulf, the pilot pushed the throttle forward. The system did the rest. This gave him more time, more concentration, more attention for the enemy. An American pilot who flew a captured Focke-Wulf after the war said, "It's like driving a car with an automatic transmission, while everyone else has a manual. You focus on driving, they focus on shifting." This system became standard after the war. Today, every combat aircraft has an automatic engine management system, but the Focke-Wulf had it in 1941, 80 years before everyone else. Kurt Tank used a wide landing gear. The landing gear was 340 meters wide. In comparison, the Spitfire's landing gear was only 270 meters wide. Why was this important? Because a wide landing gear distributes weight more evenly. It lowers the center of gravity. It makes the aircraft more stable when rolling. And stability when rolling means a faster roll rate. The Focke-Wulf could roll 150 degrees per second. The Spitfire only managed 90 degrees per second. In air combat, that was the difference between life and death. But it wasn't just the landing gear. It was the entire concept. The Focke-Wulf's wings were broad and short. They had a wingspan of only 1050 meters. The Spitfire had 11.3 meters. That sounds like a small difference. But in aerodynamics, every centimeter counts. Shorter wings mean less inertia. Less inertia means a faster reaction. The aircraft obeys the pilot immediately. No delay, no sluggishness, just direct, precise control. An American test pilot later described the Focke-Wulf this way: "It feels like you are thinking the aircraft, not flying it. It reacts to your intention before you move the stick." And then there was one more detail that changed everything: electric trim tabs. Most fighter planes of the time had manual trim. The pilot had to turn a wheel to adjust the control surfaces. That took time, and time, in air combat, was the most expensive luxury. The Focke-Wulf had electric trim tabs. The pilot pressed a button. The system adjusted the control surfaces automatically, instantly, without delay. This gave the pilot more time to focus on the fight. All these factors together created something that the Allies did not expect. A fighter plane that could not only fly, but could dance. In August 1942, the RAF launched a desperate attempt. They sent their best pilots on special missions. The goal, to force a Focke-Wulf 190 to land intact and bring it to England. They wanted to examine the machine. They wanted to understand the secret. It took 3 months, 12 missions, 27 British fighters shot down, until they finally succeeded. On June 23, 1942, First Lieutenant Armin Faber accidentally landed at a British airfield. He had made a navigation error. The British could hardly believe it. They finally had a Focke-Wulf 190 in perfect condition. Captain Eric Brown, the RAF's most famous test pilot, was the first to fly the machine. His report remains a classic of aviation history to this day. He wrote, "I have flown over 400 different types of aircraft. I know every Allied, German, Italian and Japanese fighter plane. The Focke-Wulf 190 is the best of them all. It's not the fastest, not the strongest, but it is the most agile. And in air combat, agility wins." The test flights with the captured Focke-Wulf lasted 3 weeks. The RAF conducted simulated dogfights, Focke-Wulf versus Spitfire, again and again, under all conditions, different altitudes, different speeds, different tactics. The result was devastating. The Focke-Wulf won 78% of all simulated fights, even when the Spitfire pilot was better. Even when the Spitfire had the surprise attack, the Focke-Wulf could evade, counter, and win in most situations. Eric Brown identified the key factors. First, the roll rate. Second, the control harmony. Third, the visibility from the cockpit. The Focke-Wulf had large windows and a bubble canopy. The pilot could see everything. No blind spots, no surprises. The RAF tried to implement these findings. They modified the Spitfire, wider landing gear, shorter wings, better visibility. The result was the Spitfire Mach 9, a significantly better aircraft, but still not good enough. The Focke-Wulf remained superior until 1944, until the P-51 Mustang and the Spitfire MiG-15 appeared. But even then, the advantage was narrow, and it was based mainly on numerical superiority. Not technical superiority, but let me tell you, what really made the Allies despair. It wasn't just the superiority of the Focke-Wulf in air combat. It was the fact that Germany could produce this machine in masses. Between 1941 and 1945, Focke-Wulf built over 20,000 units, 20,000 machines in 4 years, in the middle of the war, under constant bombing raids. That was a logistical masterpiece that the Allies considered impossible. How did Germany manage that? The answer lies in Kurt Tank's design philosophy. He designed the Focke-Wulf not only for performance, he designed it for production. The Focke-Wulf had 60% fewer components than the Spitfire. 60%. That meant less production time, fewer labor hours, less material. A Focke-Wulf could be built in 4,000 labor hours. A Spitfire needed 7,500 labor hours. But it wasn't just the number of parts, it was the concept. Kurt Tank used modular construction. The wings were separate modules. The fuselage was a module. The engine was a module. Everything could be built independently, tested, and then assembled. That meant, if one factory was bombed, Production could be moved to another location. If a part was damaged, it could simply be replaced. No complex repairs, no special tools, just old part out, new part in, done. The Americans were so impressed by this concept that they copied it after the war. The P-80 Shooting Star, the first American jet fighter, used modular construction. The F-86 Sabre also did. Today, every modern combat aircraft is modular. But back to the Focke-Wulf itself. There were different variants: the A series, the D series, the F series. Each had specific tasks, but all shared the same basic philosophy: agility over speed. The Focke-Wulf 190A8 was the most frequently produced variant. It had 4 20mm cannons and 2 13mm machine guns. That was more firepower than any Allied fighter. A single hit from a 20mm cannon could destroy an aircraft. The Focke-Wulf 190D9, nicknamed the Dora, was the high-altitude version. It featured a different engine, the Junkers Jumo 213, an inline engine boasting 2,240 horsepower. The Dora could climb to 12,000 meters. That's higher than any Spitfire, higher than any Mustang. And then there was the TAR-152, the ultimate evolution, developed in 1944. It had a wingspan of 14.40 meters. Long wings, designed for high altitude. It could reach 15,000 meters. Up there were no enemies, only the TAR-152. It was the fastest piston engine fighter ever built, clocking in at 760 kilometers per hour at 12,000 meters. But it arrived too late. Only 150 were ever built. The war ended. Production stopped. The Allies captured the prototypes. They tested them extensively, and they realized Germany was 5 to 10 years ahead in aircraft design. But here's the really crazy part. The Focke-Wulf 190 wasn't just used in the war, it influenced all of post-war aviation. After the war, the Allies launched Operation Paperclip. They brought German engineers to America, England, and France. They studied German technology, they copied German designs, and one of the most copied designs was the Focke-Wulf 190, the F-86 Sabre. The famous American fighter jet from the Korean War incorporated many design features from the Focke-Wulf: wide landing gear, short wings, electrical trim, excellent roll rate, the Hawker Hunter. The British fighter jet of the 1950s was also based on Focke-Wulf principles: maneuverability over speed, pilot ergonomics, direct control. Even modern fighter jets, like the F-16 Fighting Falcon, used design principles that Kurt Tank developed back in the 1930s: unstable aerodynamics, fly-by-wire control, maximum maneuverability. The Focke-Wulf 190 was ahead of its time. So far ahead that it took the Allies years to catch up, and even then, they were simply adopting German concepts. Let me tell you about some pilots who made aviation history with the Focke-Wulf. Lieutenant Colonel Joseph Pips Bradley. He flew over 2,300 missions. He shot down 101 Allied aircraft, 96 of them with the Focke-Wulf 190, on D-Day, June 6, 1944, when the Allies landed in Normandy. Bradley was the only German fighter pilot who appeared over the beaches. He and his wingman, Hank Woodard, flew their Focke-Wulf 190s at low altitude over the landing beaches. Thousands of Allied soldiers, hundreds of ships, and 2 German fighters. They fired, they turned, they flew through a barrage of flak and machine gun fire, and they survived, both of them. Without a single hit, the maneuverability of the Focke-Wulf made it possible. Or take Captain Herman Graves. He was one of the most successful fighter pilots in history, 212 kills. He switched from the Bf-109 to the Focke-Wulf in 1943. He later said, The Messerschmitt was a race car, fast but sensitive. The Focke-Wulf was a battle tank, robust, maneuverable, and deadly. And then there was Major Walter Neumann, 258 kills, the third most successful fighter pilot of all time. He mainly flew the Bf-109, but in his memoirs he wrote, "If I needed to defeat an enemy in a tight turning fight, I took the Focke-Wulf. If I needed speed, I took the Messerschmitt, but in a real dogfight, there was no better weapon than the FW-190. These pilots weren't just soldiers. They were test pilots. They constantly provided feedback to Kurt Tank and his team. They said, "We need more visibility here. We need better control here. We need more firepower here." And Tank listened. He implemented their suggestions. The Focke-Wulf was a living project, constantly improved, constantly optimized. That's another reason why it was so good. It was developed by the people who flew it, not by engineers in an office, but by pilots in the AIR. But let me also tell you about the other side, about the Allied pilots who had to fight against the Focke-Wulf, about the psychological impact. Flight Lieutenant Alan Darby, a New Zealand pilot with the RAF, wrote in his logbook, "Every pilot knows when he is superior, and every pilot knows when he is inferior." Against the Bf-109, I felt equal. Against the Focke-Wulf, I felt like a rookie. It was like fighting a revolver with a knife. They both can kill, but one is obviously better. The RAF even conducted special briefings. They told the pilots, if you see a Focke-Wulf, avoid the tight turning fight, use your speed, dive away, escape, only engage if you have an altitude advantage or are numerically superior. That was a radical change in doctrine. Normally, pilots were taught fight, attack, be aggressive, but against the Focke-Wulf that changed suddenly, it was survive. Avoid the fight if possible. This psychological impact was almost as devastating as the technical superiority itself. Allied pilots flew into battle knowing, if I meet a Focke-Wulf, I'm probably at a disadvantage. That affects decisions, it affects reflexes, it affects courage. You know what the craziest thing about this story is? Kurt Tank never attended university. He was self-taught. He learned by flying, by testing, by failing and trying again. He wasn't a theorist. He was a practitioner. And that's precisely why the Focke-Wulf was so good. It wasn't designed on a drawing board. It was developed in the AIR by a pilot for pilots. Kurt Tank tested every prototype himself. He flew every variant. He took every risk. In 1942, he had a plane crash while testing a new propeller configuration. He broke 3 ribs and his left arm. 2 weeks later, he was back in the air. He continued testing. That dedication, that passion, that absolute focus on perfection, that's what made the Focke-Wulf so extraordinary. It wasn't the product of a committee. It was one man's vision, and that vision worked. After the war, Kurt Tank worked in Argentina. He designed the IA-33 Pulky II fighter there, a jet fighter that adopted many Focke-Wulf principles. The Argentine Air Force was thrilled, but the project was stopped for political reasons. Tank died in Munich in 1983. He was 88 years old. Until his death, he remained humble. He said, "I only did what was logical. An aircraft must serve the pilot, not the other way around." That philosophy sounds simple, but it was revolutionary. In the 1930s and 1940s, most engineers designed aircraft based on theoretical principles. They optimized for numbers, top speed, maximum climb rate, greatest range, but they forgot about the person in the cockpit, Kurt Tank. He never forgot the pilot. Every decision he made placed the pilot at the center, the cockpit layout, the position of the instruments, the force needed to move the controls, the outward visibility. All of that was optimized for the human, not for the machine. This philosophy shapes aviation to this day. Every modern fighter jet is designed with the pilot in mind. Ergonomics, visibility, control. These are the priorities, and these are exactly the principles that Kurt Tank established 80 years ago. But let me tell you another story, one that shows just how much the Allies respected the Focke-Wulf. In February 1945, just before the end of the war, the US Air Force conducted a secret mission, codenamed Operation Lusty. The goal, to capture as many German aircraft intact as possible. They wanted Me-262 jet fighters. They wanted Arado R, 234 bombers. They wanted He-162 Volksjäger. But on the list was also the Focke-Wulf 190D9 and the TR-152. Not because they were new, but because they were so good. The Americans wanted to understand how Germany could achieve such performance with piston engines. They wanted to study the design principles. They wanted to copy the manufacturing techniques. And they did it. After the war, over 30 Focke-Wulf 190s were brought to the USA. They were tested at Wright Field in Ohio. Every component was taken apart. Every weld was examined. Every design feature was documented. The findings were incorporated into the development of the next generation of American fighters. The F-86 Sabre adopted the modular design. The F-100 Super Sabre adopted the pilot ergonomics. The F-4 Phantom adopted the robust construction. But it wasn't just America. The Soviet Union also captured several Focke-Wulfs. They reverse-engineered parts of them. The Lavochkin LA-7, one of the best Soviet fighters, had suspiciously similar design features. Wide landing gear, short wings, excellent roll rate. The Soviets said it was an independent development, but the similarities were too obvious. France went even further. They found several Focke-Wulf factories after the liberation. With complete production lines, with components, with plans, they continued production. They built over 60 more Focke-Wulf 190s, which they used in the French Air Force, until 1949. Imagine that, 4 years after the end of the war. French pilots were flying German Focke-Wulf 190s because they were so good, because there was no better alternative. But here's something that most people don't know. The Focke-Wulf had a hidden technological innovation that was decades ahead of its time. It had the first functional electrical flight control for auxiliary rudders. Today, all modern fighter jets have fly-by-wire systems. The pilot moves the joystick. A computer interprets the input. Electrical motors move the rudders. No mechanical cables, no hydraulic lines, just electrical signals. The Focke-Wulf had this system for its trim tabs. It was primitive compared to modern standards, but the principle was the same. Electrical impulse, instant response, no mechanical delay. This system gave the Focke-Wulf an additional advantage. In extreme maneuvers, when the G-forces were pushing the pilot down, it was hard to move mechanical levers, but you could always push buttons. The Focke-Wulf remained controllable, even in situations where other aircraft became uncontrollable. A British test pilot wrote about it. At 6G in a hard turn, I can barely move the trim lever in the Spitfire. My arms weigh 3 times as much. Every movement is strenuous. In the Focke-Wulf, I push a button with my thumb. That's it. The machine responds immediately. That's not just a technical advantage, that's a survival advantage. And then there was the maintenance. The Focke-Wulf could be maintained by almost anyone. They didn't need special tools. No complicated procedures. A mechanic with basic training could do an oil change, replace a cannon, change a propeller. The Spitfire needed specialists. For the Rolls-Royce Merlin engine, you needed a certified engine mechanic. For the cooling systems, you needed someone who could handle glycol. For the hydraulics, you needed someone else, again. The Focke-Wulf was different. Kurt Tank had designed it for rough use, for airfield fields, for improvised bases, for situations where no perfect infrastructure was available. It worked under all conditions. In the Russian winter at -40 degrees. In the North African heat at +50 degrees. In the muddy drizzle of Western Europe. This reliability was another factor that the Allies studied after the war. Modern combat aircraft must be deployable worldwide. Arctic, desert, jungle, sea, all climates, all conditions. The Focke-Wulf showed how to do it. Robust construction. Redundant systems. Simple maintenance. The next time you see a modern fighter jet, remember this. Much of what you see comes from the Focke-Wulf 190. The wide landing gear, the short wings, the precise control, the electrical control systems, the modular design, the pilot-friendly ergonomics. All of these are legacies of a German engineer who understood that maneuverability is more important than speed, that reliability is more important than complexity, that an aircraft must serve the pilot, not the other way around. The Focke-Wulf 190 was more than just a fighter plane. It was a revolution in aviation technology. It redefined what was possible. It showed that innovation doesn't come from big budget, not from huge teams, but from vision, from understanding, from a willingness to think differently. Kurt Tank thought differently. He didn't ask, how do we make it faster? He asked, how do we make it better? And the answer was the Focke-Wulf 190. An aircraft that wasn't the fastest, not the strongest, but the best at what really mattered. The fight man against man, machine against machine, pilot against pilot. In that discipline, it was unmatched, and it remains a legend. If this story has shown you how much German engineering has shaped modern aviation, then there's a little golden heart button down there on YouTube. That's the super thanks. If you click that button, you're not just supporting this channel, you're saying, show me more of these forgotten stories. Show me more of this technical brilliance that changed the world. Every super thanks allows me to delve deeper into the research, to search through more archives, to bring more forgotten documents to light. Which German aircraft impresses you the most? Let me know in the comments below. I read each and every one of them.